So when you say cogeneration, the first thing you hear is the prefix co, as in cooperate, co-pilot, coexist. The first syllable co means together. Cogeneration therefore means creating or producing something together. In the construction industry, the word refers to the simultaneous production of electricity and heat. This source can be a turbine or combustion engine, for example.
More concretely, what does the term cogeneration actually mean?
And how is this idea reinventing the world of tomorrow? I'm James.
And I'm Amy. Together, let's decode the ideas that are shaping the future of sustainable construction.
Constructing New Worlds by Saint-Gobain. Behind words, solutions, and innovations for a sustainable future. As I was saying, cogeneration is the production of electricity and heat from a single fuel source at the same power plant. On the one hand, heat released by industrial sites can be used to turn turbines and generate electricity. On the other hand, turbines or combustion engines that produce electricity release a lot of heat that is often wasted. At a cogeneration plant, this heat is captured and used to heat water. This hot water can then be put to use, for example, to heat homes and businesses through the hot water network.
Right now, only major infrastructure like shopping malls are making use of this technology. The plan is to deploy cogeneration on a much broader scale. We see the technology mostly in industrial facilities or serving entire districts.
Yeah, like Tilbury Power Station in England. It started out being fueled by coal. Then in 2011, it was converted to a cogeneration plant fueled by biomass. It went on to produce both heat and electricity thanks to burning wood pellets and other biomass sources.
So cogeneration is kind of like the future of heating?
Yeah, that's the plan. Heat networks for buildings are constantly being updated and adapted to new energy sources. Let's rewind a bit.
Okay.
The first district heating system was introduced over 100 years ago. It consisted of piping very high-temperature steam through a network to provide heat to buildings. Later, steam was replaced with water, still at a high temperature, over 100 degrees Celsius.
Wow.
Yeah. In the next generation systems, though, the use of insulated distribution pipes allowed them to lower the temperature in the heating networks. This was a significant change as it reduced the amount of energy used to produce the heat. After all, Amy, the hotter the water, the more fuel you need to heat it, right? At the same time, demand on fuel has been reduced thanks to advances made in the energy performance of buildings.
And cogeneration goes even further because it produces more energy while consuming less. So, in theory, it makes good economic sense as well as environmental.
Right, but it's not all plain sailing.
No, James, unfortunately it's not. These benefits can only be reaped if a building equipped with this technology is well insulated and highly energy efficient, which is generally not the case.
Yeah, and not every building is designed to accommodate the technology required. The initial outlay to install the system can be exorbitant, not just in terms of building the power station itself, but connecting it to the public grid. The technical complexity of the system can also be a deal breaker because it calls for quite specialized expertise. Plus, a cogeneration system will require regular maintenance, which can incur greater operating costs.
And speaking of significant costs, the size of the carbon footprint still depends on the fuel used. It's true that cogeneration power stations can be fueled by biomass, like in Tilbury or Masnedo in Denmark. But if fossil fuels are used, pollution is still generated. Harmful nitrogen dioxides and fine particles are pumped into the air. So more has to be done to ensure that cogeneration is a viable solution, especially from an ecological perspective.
Let's be honest. Cogeneration isn't a technology we're going to see everywhere right now, right away. But it is highly promising in the long term. For example, gas boilers in buildings can be replaced with hot water piped through distribution networks, at the same time as energy renovation work is carried out to make a building more energy efficient. Together, these measures can generate important positive economic and environmental impacts.
But the entire system needs to be well designed and properly scaled. Otherwise, any of these potential pros may just become cons. But if over the next few years we design power plants more suited to residential areas, then this solution could be harnessed in the not-too-distant future.
Constructing New Worlds by Saint-Gobain.
Behind words, solutions, and innovations for a sustainable future.